Hello friends, today we will understand how to use a steam table and read properties, thermodynamic properties from a steam table. For this we should first understand the PV diagram of real fluids. As you can see, the PV diagram is a dome. On the top of the dome we have the critical point, and on the left from the critical point downward we have the saturated liquid line, and to the right we have the saturated vapor line. Saturated liquid line is the point at which the first drop of vapors occur in a body of fluid when it is being heated. The saturated vapor line is the line when a fluid is cooled from its vapor state. The first drops of liquid that occur in the vapor. In between the saturated liquid line and the saturated vapor line, we have the two-phase region where the liquid is a mixture, or the fluid is a mixture of liquid and vapors. Now let us understand this further. Let's take a fluid which is at point capital A, the orange point. At constant pressure, we start heating it up. At point B, the first droplet of vapors form in the body of the liquid. This point B falls on the saturated liquid line. Further, if we heat it up, boiling starts and the liquid is converted into vapor. At point C, all the liquid that we are heating is fully converted to vapor. Beyond point C, if the vapors are heated, they become superheated vapor. So point D is a superheated vapor point. The line ABCD is an isobar. Now let's take a fluid which is at point A, small a. It is an isotherm. From point A to point B, we have an isotherm. The isotherm starts from A, B, continues on to C, goes to point D. Now, what is an isotherm? An isotherm is a line where the temperature is constant. Now, from point A, we slowly reduce the pressure on the fluid and we come to point B. The volume increases slightly. At point B, the first droplets of vapor occur in the body of the fluid. From B to C, the fluid starts boiling. A very slight reduction in the pressure will cause the boiling of the fluid. The pressure at point B and at point C is practically constant, and it is known as the saturated vapor pressure. At point C, all the liquid has converted itself into vapor. Now from C to D, if the pressure is reduced, the vapor is superheated. Now let's have a look at a pressure enthalpy diagram. If you take a liquid and at constant pressure, heat it up. Let's take point A for example, and at constant pressure, let us heat it up till point B, where the point B falls on the saturated liquid line. The enthalpy required would be the Cp of the liquid multiplied by the saturated temperature minus the temperature at A. Further, if we heat it up, the fluid boils, and at point C, we get saturated vapors. The heat required is equal to the latent heat. and the enthalpy change is equal to the latent heat. The enthalpy difference between point C and point B is nothing but the latent heat, and the latent heat is nothing but the change in enthalpy, vice versa. Now, from point C to point D, when we heat up the vapors, the enthalpy required is the specific heat of the vapor, that is Cp vapor, multiplied by temperature at D minus the saturated vapor temperature or the saturation temperature of the fluid. Now let's take the PV diagram once again and look at it, that what points of the PV diagram are represented on a steam table. If you open a steam table, the first entry is going to be temperature. Now the temperature here is the temperature of the isotherm, which is shown by the green line. The Psat is the saturated vapor pressure. It is the pressure at which the liquid or water starts boiling at 200 degrees Celsius. VL is the volume or the specific volume of the liquid water at saturated liquid line, or we can say it is the volume of saturated water liquid, and VV is the volume of the saturated vapor of water. As we can see here, that the difference between the saturated liquid volume and the saturated vapor volume is extremely high. Now let's look what points on a pH diagram is represented in a steam table. The steam table is actually a representation of the pressure enthalpy diagram. Now, in the steam table, the first entry is temperature. This was already explained. The saturated vapor pressure. This was already explained to you. This is followed by the volume of the liquid and saturated volume of the vapor. Next, we have the enthalpy of the saturated liquid. This is this point. It is the enthalpy of the saturated liquid water. The last column is the enthalpy of the saturated water vapors. And delta H or HLV is nothing but lambda. It is the difference of HV and HL. Let's go to the next slide. Yes. Now, beyond the saturated vapor line, we have the superheated region of the vapor. Now, in any steam table, you also have the superheated region tables. These tables are pressure wise, they are written as functions of pressure. So let's take an example at 100 kPa pressure, at temperature, the saturated temperature, which is this point, the enthalpy at this point is 2675.5. So the first entry, that is SAT, will give you the enthalpy of the saturated vapor. The second entry, 100 degrees Celsius, is the enthalpy of the steam, which is at 100 kilopascal but is superheated to 100 degrees Celsius. The third entry is the enthalpy value of superheated steam, which is superheated at 100 kilopascal, 150 degrees Celsius. Hope you have understood what are the meaning of the entries in the steam table. If you have any queries, message it to me. Subscribe my channel for more ideas and lessons on thermodynamics, and have a great day. Bye.